Man had released energy from within the atom in the first atomic blast. One of nature's greatest energies hitherto undreamed of, and creating which have confounded mankind. We are apt to think of atomic energy as something new. But God placed this fabulous energy in every bit of matter when he created it. In fact, the earth has been warmed and lighted by atomic energy from the beginning, for the energy of the sun is atomic energy. No, atomic energy is not new. But now that man can control energy, the world is faced with problems. But the question arises, just what is atomic energy? Well, let's begin back at the beginning. Perhaps it can be said that the cornerstone of our knowledge in this atomic age was laid back in the year 1905, when an unknown clerk in a Swiss patent office scribbled strange equations at his desk. Here, about half a century ago, Albert Einstein gave to the world E equals mc squared. Energy, the equivalent of mass. A radically new conception, key to the atomic age. The idea expressed in E equals mc squared is actually quite simple, but it has caused a great revolution in scientific thinking. It means that any object, this desk, pencil, piece of paper, just any bit of matter represents an unbelievable amount of energy. For example, the atomic energy in, just the paper of this book is the equivalent of the power produced by Hoover Dam in 1 full year of operation, enough to supply the electrical needs of your home for 1 million years. Air is a fragile thing, yet in a single breath is energy equivalent to the burning of 200,000 gallons of high-octane gasoline, sufficient fuel to fly a giant 4-engined airliner to the moon. Within just the paper of this railroad ticket is enough energy to power a cracked diesel-electric streamliner 3 times around the world. In fact, the atomic energy in 1 pound of any kind of matter, a pint of water, for example, is the equivalent of the burning of 1.5 million tons of coal. Now, of course, this doesn't mean that you can take a pint of water and pour it in the gas tank of your family car, take off on a trip around the world, but the energy is there, hidden down inside the tiny particles of which all matter is made. In order to understand this properly, we must know something about the structure of matter. Matter may exist in any one of 3 states. The same substance may be either a solid, a liquid, or a gas, depending upon its temperature and the pressure. Water is a good example. It may be a solid, ice, or a liquid, or a gas. But even in the gaseous state, it's still H2O. What do we mean when we describe water as H2O? And what does all this have to do with atomic energy? Well, to grasp what this simple formula really means is to understand some of the basic laws governing the structure of all matter. Electrolysis apparatus will help us understand why the chemist has called water H2O. The glass tubes of the apparatus are filled with water from the reservoir above. At the base of the tubes, an electric current is caused to flow through the water from one platinum-tipped electrode to the other. Immediately, bubbles of gas form and go streaming upward. Graduated scales on the tubes indicate the proportion in which these gases are released. On one tube, we read 20. On the other, 10. The greater amount of gas burns with an almost invisible blue flame, hydrogen. The other gas causes a glowing splint to burst into flame. This is oxygen. So we say that water is composed of two gases, hydrogen and oxygen, combined in a proportion of 2 to 1. Two particles called atoms of hydrogen are combined with one atom of oxygen to form a molecule of water, H2O. Two colorless, odorless, invisible gases combine to form a liquid. Individual atoms of any substance are much too small to be seen. If we had 1 million of them in a pile, we couldn't even see the pile. You might say, well, if we can't see atoms, how do we know that they exist? Well, there are a number of ways that we can detect their presence. Brownian motion is one of them. If we draw the smoke of an ordinary match into a smoke chamber and then place it on the stage of a very high-power microscope with dark field illumination, we can see something that is really quite amazing. Notice the white spots. They're smoke particles. Why are they moving? They're being buffeted about by invisible particles of air. Air pressure is merely the resultant of untold billions of these particles bombarding an object. At sea level, their combined pressure is 14 7/10 pounds per square inch. That means that on a can like this, there are some 8 tons of pressure exerted on the surface. Why doesn't it collapse? Well, that's because air molecules on the inside are exerting an equal but opposite force. Of course, the velocity of the air particles is determined by their temperature. As the temperature goes up, their speed increases. So let's heat the air inside the can. The air molecules inside the can, here mixed with water molecules, are speeding up. And so some of them are forced out of the can. This smaller number inside, going faster, equalize the outside pressure. But now let's turn the heat off and put the cap tightly on the can so that none of the particles we have driven out can get back inside. As the air inside cools off, these particles slow down and wage a losing battle against the greater number of particles, hammering on the outside, and the can collapses. The effects of air pressure, the movement of the smoke particles, are evidences of the existence of these invisible particles, but certainly they're not the only evidences. For the whole atomic age is built upon certain and positive knowledge of their existence.